So in this video, we're going to be looking at imaginary numbers. So let's look at imaginary number. The basic definition of imaginary number is the square root of a negative 1. Okay, so I is equal to the square root of negative 1. Okay, now let's use some properties of radicals. Okay, we're going to put this to a square. Therefore, this is going to be I squared is equal to negative 1. And always remember, conversely, the logic in here is that I is equal to the square root of negative 1. Okay, so let's give you an example, quick examples immediately. Let's say you are given the square root of negative 25. Okay, with imaginary numbers, we can now solve this one. Negative 25 is the same as the square root of negative 1 multiplied by the square root of 25. Okay, so whenever you see the square root of negative 1, change it with I, and 25 is going to be, the square root of 25 is going to be 5. Now we're just going to get the principal root, which is 5. So this is going to give you 5i. Okay, so that's how simple it is. Let's give you another one. So let's say, for example, you are given, you're going to be given negative 36. Okay, so negative 36 is the same as the square root of negative 1 multiplied by the square root of 36. Okay, whenever you see the square root of negative 1, change it with I multiplied by the square root of 36, which is 6. So we're going to say it's going to be 6i. Okay, so these are short examples of how the imaginary number is being used. Complex numbers. Complex numbers is the sum of a real number and an imaginary number. So let's give you an example. Okay, complex numbers comes in the form of a plus bi. So in here, we're going to look at this a as your real number and bi is your imaginary number. Okay, so that's the very basic one. So let's see. Let's give you examples of a complex number. Complex number can be, let's say, 3 plus 2i. Okay, we can also say 34i. We can also say 72i, and so forth. You can also say 2 plus 5i. So these are the forms of complex numbers. Multiplying complex numbers. Say we have 4 plus 3i multiplied by 2 minus 5i. We are going to simply FOIL it. Okay, so this is going to give you the first and the first terms. That's going to give you 4 times 2 is 8 minus 20i plus 6i minus 15i squared. Now remember, whenever you see I squared, you change it with negative 1. Okay, so let's simplify further. This is going to be 8 negative 20i plus 6i. This is going to give you negative 14i plus 15 now. Okay, what did I do? Because whenever I see I squared in here, just like this one, I'm going to multiply this by negative 1. So negative 15 multiplied by negative 1 is going to give you positive 15. Okay, simplifying further, this is going to give you 8 plus 15 is going to be 23 minus 14i. Okay, that's how you're going to do it. Okay, let's say there's another one. Example, 3 minus 4i multiplied by 2 plus 3i. So we're going to FOIL the same thing. Always remember that whenever you see I squared, you change it with negative 1. Okay, so 3 times 2, that's gonna give you 6. 3 times 3i is gonna give you plus 9i, negative 8i, and then negative 12I squared. So I saw the I squared in there. So I can now change this with your negative 1. Okay, so simplify further. That's going to be 6. This is going to be 9 minus 8I. So it's going to give you only 1I, or simply plus I and then plus 12. So 6 plus 12 is going to give you 18 plus I. Okay, as simple as that. It is also possible to find the product of this example. Let's say you are given 4 times 2 plus 5i. So we just simply distribute this one. So this is going to give you 4 times 2 is 8 plus 4 times 5i is going to give you 20i. So simply that is your answer. Dividing complex numbers, one of the very most important concept that you have to remember is the concept of complex conjugate. Okay, the complex conjugate simply says that, say for example you are given a plus bi, the conjugate of it is the opposite, which is a minus bi, and vice versa. Okay, also example, you are given 2 plus I root 5. The conjugate of that is going to be the opposite sign, which is 2 minus I square root of 5. So these are what you call your conjugates. This is very important for you to know. Now, say for example, you're going to be given negative 1/2 I. So in its full form, this is going to be 0 minus 1 over 2i. Now, if you're going to find the conjugate of this, the conjugate is going to be 0 plus 1/2 I. So I hope you're going to remember this. Okay, so say for example, we have 2 plus 5i, and we divide it by 4i. So remember earlier I said the complex conjugate. So 4 minus I, the complex conjugate of this is going to be 4 plus I all over 4 plus I. Now also remember one thing in when you're going to say example A minus B, and you're going to multiply it by A plus B, the product of that is just going to be A squared minus B squared. Now this form is going to be like in your denominator. So it's now going to be easier for you to be looking at, and you don't have to do the long cut way. Okay, so let's perform the operation in here. So we're going to FOIL that. 2 times 4, that's going to give you 8. 2 times I is going to give you plus 2i. 5 times 4i is going to give you 20i. And 5i times I is going to give you 5i squared. Okay, now remember again that whenever you see I squared, you have to exchange it with negative 1. So in this case, I'm going to change this with negative 1 now. It's going to be multiplied by negative 1. Now below, we're going to apply this principle. So you have 4 squared minus I squared. Okay, so I saw I squared again in there. Therefore, my I squared is going to be negative 1. Okay, simplifying it further. So this is going to give you 8 minus 5 already. 8 minus 5. And then you're going to have 2i plus 2i plus 20i. It's going to give you 22i all over 16 plus 1. Simplifying further, 8 minus 5 is going to give you 3 plus 22i all over 16 plus 1 is 17. Now, in order to put this in its complex form, you're going to break out these things. It means to say that you're going to write it as 3 over 17 plus 22 all over 17i. So this is in the form of complex number a plus bi. So in division, you have to always remember that you have to put your answers in this form all the time. Okay, so you're given a function of x squared minus 5x plus 2, and we're going to evaluate it using f of 3 plus I. So that's going to give you 3 plus I. That's going to give you 3 plus I square minus 5 times 3 plus I plus 2. Key point to remember here, whenever you see I squared, substitute it with negative 1. Okay, let's continue this one. Let's expand this one now. So that's going to give you 3 square. Okay, 3 times 2, that's going to give you 6I. Then plus I squared. There you go. There's another I squared in there. For sure, I can exchange that with negative 1 now. Continuing the process, we're going to distribute this one, negative 15 minus 5I plus 2. Expanding further, that's going to give you 9 plus 6I minus 1. Then minus 15 minus 5I plus 2. Okay, so if you're going to simplify all of this, you only have 6I and negative 5I. That's going to give you plus I. Now you have 9 minus 1 minus 15 plus 2. That's going to give you negative 5. So this is your final answer. So say, for example, we are given this function 2x squared minus 3x, and let's evaluate it with f of 8 minus I. Okay, so let's say f of 8 minus I, that's going to give you 2 times 8 minus I square minus 3 times 8 minus I. Okay, key point again, whenever you see I squared, substitute it with negative 1. Okay, let's expand this one. That's going to give you 8 square minus 2 times 8 is going to give you 16I, and then this is going to be plus, it's going to give you I squared. There you go. So I saw my I squared in here. I'm going to change this one with negative 1 right now there. Okay, so we are going to distribute this one in here. So that's going to give you negative 24. 3 times 8 is 24 plus 3I. So continuing with the process, 8 squared is going to give you 64 minus 16I. Negative 1 is going to give you minus 1. And then this is going to give you minus 24 plus 3I. Okay, so we're going to continue with this. So this is going to give you 2 times 64 is going to give you 128. This is going to give you negative 32I minus 2 minus 24 plus 3I. Okay, so let's put all the real together, and we're going to put all the imaginary together. Our real is here, this one, this one, this one. 128 minus 2 minus 24, that's gonna give you 102. Negative 32I plus 3I is going to give you negative 29I. Okay, so it is already in the form of a plus bi. Therefore, that's actually your answer in here. Simplifying the powers of I. So the first thing I would like to establish in here is the powers of I. I raised to 1, that's going to give you simply I. I to 2, that's going to give you negative 1. I to 3 is equal to negative I. And I4 is equal to positive 1. So let's look at it. In this case, I is simply I. Okay, in this case, you are going to have I times I is going to give you I squared, and I squared is negative 1. In here, we have I3. Of course, we know that I2 times I1 is going to give you I3, but I squared is going to be negative 1 multiplied by I again, Therefore, it's going to give you negative I. And the last, that's going to be I4. I squared times I squared. Okay, we know that's going to be negative 1 times negative 1, and it's going to give you a positive 1. So this is the cycle of simplifying the powers of I. Okay, for example, we're going to be simplifying, let's say, I raised to 35. Okay, I raised to 35. What is the value of I raised to 35? Using all of this, we know that I4 is 1. Now, so we're going to divide 35 divided by 4. So how many 4s in 35? That's gonna give you actually 8. Plus add 3 more. That's going to be a total of 35. So let's say I4 raised to 8. Okay, that's gonna give you 32. Then I'm going to add more 3. That's going to be I cube. So that's going to give you I4 is 1 raised to 8 multiplied by I cube. We know that our I cube is negative I. Okay, here I cube. Okay, then we will further do this one. 1 raised to 8 will always be 1, but I cube is going to be negative I. Therefore, the answer to that is negative I. Okay? Okay, let's say we're going to put I raised to 8. Okay? So, we establish that I4, okay, 8 divided by 4 is 2. Therefore, I4 is equivalent to 1 raised to 2. So simply 1. Okay. What about I22? Okay, so how many 4s in 22? Okay, so actually we have 5, then add more. So add 2 more. Okay, so that's going to give you I4 raised to 5 times I squared. Now I4 is 1 raised to 5 multiplied by I squared. And we know I squared is, the value of I squared is negative 1. Therefore, 1 times negative 1 is going to give you negative 1. Okay, that's how you're going to evaluate the powers of I.